Hello everyone, welcome to the Bhairav Show. I have Dr. Vikram with me here. He's the co-founder of needl.ai, and he's been in academia at NUS, and he's also worked at Bell Laboratories, and he's been an ex-founder, currently a co-founder at needl.ai. Welcome, Dr. Vikram, to the show.
Thanks. Thanks, Suhas. You can just call me Vikram. It's
All right.
perfect.
Yeah. All right, Vikram. Yeah. Thank you very much. And I'd like to begin with like how did your journey from research and technology move you into entrepreneurship?
Sure. Yeah, so I mean, I did my PhD at UC San Diego. I was always, I guess, very curiosity driven and loved research and academia, and I was publishing well. Then I was in Singapore. I was a faculty member there. Um, I was publishing very well. I had some fantastic PhD students. But then I wanted to move closer to impact. At the point of time I was in Singapore, it was primarily a financial hub. It was not the tech hub it is today. So I decided to move back to India, and I wanted to do something that could potentially make impact, not just publish research papers. So there was a interesting opening at Bell Labs Research in India. So I joined the research group here at Bell Labs India. We did a bunch of interesting work, but again, translating research into product, even within industrial labs, is a long journey. So I spent a few years there, and then one of my mentors, who's been a serial entrepreneur and a value veteran, called me out of the blue one day saying he was going to be starting a startup, and if I knew anyone who would be interested in joining a startup. So I knew my mentor very well for over 25 years. I knew that anything that he would do would be interesting, and I would learn a bunch. So I sort of jumped ship and joined him on my earlier startup, Zetata, which was building search technology for e-commerce retailers. And that was a fantastic journey. We got acquired by Target eventually, which is a US-based retailer. And yeah, that journey was exhilarating. It was fun. It sort of opened my mind to whole new ways of thinking about things. So I loved it. And then, so once Zetata happened, Target happened, and we had transitioned our tech into Target, I realized I wanted to get back on the entrepreneurial journey again, and which is why I started needl.ai.
Okay. And is there any specific problem that led you into needle.ai? Because you mentioned about search.
Yeah. So I think search. So once I got into search and I realized what a fascinating problem it was. So I kind of knew that I wanted to be around that space, search, AI, ML. That's the space I wanted to be in. So at that point of time, I met my co-founder, Kuntal Shah. So Kuntal is this absolutely brilliant investor who's been an investor in the Indian markets for 30 years. And we got talking, and he had a sort of he was talking about this personal pain point, which is he had all of this information scattered across data silos in different data sources, different data silos. And as an investor, he needed to sort of weed out the signal from the noise. And as data volumes were growing exponentially, he was finding this harder and harder to do, right? So we got talking, and I said, I'd love to take a shot at this, a crack at this, because this was a hard problem. We're talking about, data coming from, everything from an exchange like Bombay Stock Exchange to SEC to information residing in drives coming from your emails. And a lot of these are very complex financial documents, right? It's not simple data, simple documents, but complex PDFs, Excel, PowerPoints, all kinds of information, right? So the scope and scale of what we had to do was super exciting. I knew it was an exceptionally hard problem to solve. And so it sort of scratched many of my itches. I knew it was a very hard problem to solve, not really a well-solved problem yet, and there was a clear business need, right? And so I ticked all the boxes, and hence ended up starting needl.ai.
Okay. And you mentioned about it's a problem that takes time to solve as well. Is it more of an approximation problem that you're trying to solve within an enterprise search space, especially when it comes to, let's say, enterprise search?
So enterprise search space, I mean, again, when you say approximation problem, I think you're coming from the point of view of NP hardness, interpretation.
Exactly, yes.
Algorithms. Yeah, when I say it's a hard problem, I don't necessarily mean computationally hard problem. I mean,
Okay.
the complexity comes from the scale of data, the variety of data, the volume. So one part of the complexity just comes from the engineering complexity of designing something that works at scale. One part of the complexity comes from just the relevance algorithms that you need to design so that you return the right results to the customer in a timely fashion, right? Because when you're making high stakes financial decisions, you cannot, both precision and recall start becoming very, very important, right? So how do you sort of design for systems that can operate at scale, operate with very complex types of information, and yet return highly meaningful results so that our enterprise customers can make decisions, high value decisions which are, millions and hundreds of millions of dollars kind of decisions with confidence, right? So
Mm.
that's the problem we're going after.
Okay. And you mentioned, especially given the fact that you're dealing with financial data, you also
Right.
deal with multimodal data, right?
Yeah.
So, how do you think search has evolved with the uh, advent of large language models, especially with respect to multimodal nature of data, right?
Yeah.
Before you
Yeah.
started, was it entirely different? And now you would have had to deal with a different type of, or rather different set of algorithms that you had to uh, focus on in order to solve this?
Yeah. No, that's a fantastic question. So I think multimodal data was the fact that there was multimodal data was always true in
Mm,
financial services
correct.
because people are representing all kinds of information in charts, infographics, images, etc.
Mm,
Right? And these are high value distilled information that needs to be and there's value in searching across that type of information and returning it to the user, right? Now, what has changed with LLMs is, I guess at some level, it's the fact that all kinds of information are getting transformed into the same space, right?
mm, numerical
Be
representation.
same latent space. I won't go
Correct.
into what that
Sure.
latent space needs to
Sure.
be, but the fact that you can transform all of this information into the same latent space so that you can reason about it uniformly across different types of modalities, that capability has changed dramatically, right?
Okay.
And that is enabling us to do a lot of smart stuff, which we couldn't do earlier, right? Because yeah, I think that's a fundamental advance thanks to LLMs.
Okay. And how different is, let's say, an enterprise search with respect to normal web search that you come across, right? Is it
Yeah.
in terms of storage? Is it in terms of serving clients? What is it?
Yeah. So I think it's primarily, I would say, I mean, I think I've written blogs about this too. Um, so when you're doing, let me put it this way, when you're doing web search, um, the nature of the problem is very, very different, right? So let me first start with the simplest case, right, which is e-commerce search, and then I will go
Hmm.
to web search. I just build it up as a ladder.
Sure.
So let's look at e-commerce search, right? Let's say you're typing in, you're looking for a red shirt, right? If you're looking for a red shirt, as long as you return 10 red shirts to the user, that is good enough. If the 11th one is missing from the recall set, it's okay, right? It doesn't make a big difference to the decision-making capabilities of the end user, right? So relevance is important, but recall, if it's off by a little bit, it's okay, right? So that is the e-commerce search example. Now, but in the e-commerce world, where typically, right, most stores have a very finite catalog, right? It's maybe a few million document
SKUs.
catalog or product catalog or SKUs. So it's not that hard of a problem, right? Now, when you go to the web search world, again, what matters is relevance, right?
Mm.
So because the information, the underlying catalog is changing all the time, right? It's not like e-commerce search where it's a fixed catalog. The underlying catalog or universe of data or universe of information is changing all the time. So again, if you're doing a search, let's say, how do I'm getting this noise from my car engine, what could it be? Or these are my health records, what could it be? Whatever, right? Whatever you're looking for, as long as I get, 10 or 20 articles which talk about um, different people writing about what the problem could be, how to solve it, etc., you're fine. There might be a 21st article that somebody has written. There could be a 30th article that somebody has written. The additional utility from those articles is minimal. And even if you, and the problem is you don't even know that you're missing those additional pieces of information, right? You don't know what you don't know because you're operating at ginormous scale. And when you're operating at ginormous scale, as long as you get sufficient number of relevant articles, it's good enough for you to make an informed decision, right? Now let's come to the enterprise world. Enterprise world is a very, very different scenario, right? Because the user actually knows what's in the data and document set pretty much. He or she has a reasonably good idea, right? Now, if I just take you back to the e-commerce search, right, where I said red shirt, show me some 10 red shirts is good enough. In the enterprise search, or especially financial services search space, I cannot say that, I've shown you 10 red shirts. It's a slightly different scenario. I might be looking for, um, what is the most recent XIRR of some particular, what is the average broker consensus across
Mm.
different analyst reports, sell side reports. If I miss even one piece of information, the cost of making a decision based on that missed piece of information is very, very high, right? So, so first of all, there is a trade-off, right? Which is I cannot afford, my recall set has to be bang on, right? Both my recall and precision in enterprise search have to be bang on. If I
Mm.
don't get it right, as an end user, you could be making very high value decisions, which could cost millions of dollars, right? In the cost of a financial dollar, I'm making an important investment decision.
Mm.
If I missed on, let's say, somebody who's having a bear, who thinks a certain stock or a certain um, company has a bearish scenario rather than a bullish scenario, and if I've sort of not taken that disconfirming evidence into account in making my decision, that could have dramatic costs for me, right?
Mm.
So the enterprise scenario cost of missing information is very high. That is
Mm.
number one. And number two, oftentimes the user who's searching for this information sort of knows what is out there, right? So the experience of not returning that 11th piece of information from a user perspective is glaring, right? So they will immediately come to you and complain, hey, I know this document was not there. I wanted this document returned in my search results, but
Mm.
I don't see it here. Why not? I
Okay.
know it's some drive somewhere. I had filed it away maybe 2 years ago, but I'm not able to find it, right? So
Mm.
these are the problems that come up in enterprise search, which is fundamentally not there in, let's say, an e-commerce search or web scale search, right?
Okay.
So it's a much harder problem. You have much more demanding customers,
Mm.
and the cost of mistakes are much higher.
Okay. And given the fact that you're building an a market intelligence product, mainly cater to, let's say, trade analysts or people who are buying stocks, right? You also deal with real-time information to some extent. Now, how do you deal with, let's say, precision and recall, especially when you have to combine real-time information? For instance, Fed reduced their repo rate, for instance, or they increased it. Now, how do you sort of manage the algorithmic perspective to something that's already on the system and something that you've already tested it for, on thousands of iterations in order to fetch the relevant result? So how do you deal with this?
Yeah, so I think this real time is always so first of all, the customer base that we deal with, right, are not traders, right? They don't do. We are not dealing with day traders and stuff like that. We are dealing with folks in who create, for example, who make longer term if they're in on the asset. So we have different kinds of customers. So we have asset management companies which are customers. We have private equity, private credit, etc. These are the guys who need to make decisions on, let's say, data rooms, who want to make decisions on what company to invest in. But these are decisions taken somewhat slowly, right? And as in, I'm not talking about millisecond-based trades, etc. These can take multiple days, right? So that's not the problem I am dealing with at this point of time, right? So, but I do need near real time. I mean, as in, if the Fed changes rates, it has to become part of my search set, and it has to I have to serve up recent results within a reasonable period of time, right? Maybe an hour or so. I don't have to I don't have to worry about millisecond kind of granularity. So for me, it's a different problem set. What I'm primarily dealing with, complex information, complex data, and helping users make good decisions, good judgment, reach conviction quickly on what they're supposed to do, right? So it's a slightly different customer base and problem space.
Okay. And you also mentioned about certain results when not shown affects a lot, especially with respect to affects your quality, right? And people come back to you. Do you think that there are a lot of instances where customers can be comfortable with a traditional search, but now they are making a mistake in terms of expecting a normal chatbot-like interface there?
Yeah, so I think the world is moving more and more towards the chat. I mean, the chatbot interface at some level is a more intuitive interface. That is one. Second, if you give the traditional search results, there is still a lot of cognitive overload in terms of going through all of that and making a decision, right? So as to what the winning interface will be, I think is an open-ended question. I'm not, well, I won't say it's an open-ended question. My gut is it's either going to go to a pure chat interface or like what Google search now has, right? Which is the AI overview followed by the 10 blue links, right? And if I'm not mistaken, if you look at even the AI overview, the proportion of traffic that's just going to pure AI overview in Google search, it's transforming more and more towards the pure AI, right? The conversational ability and the naturalness of a chat interface is way higher, right? I compared to like scrolling and clicking on links and understanding what each says. This sort of does a lot of that grunge work for you, right? So if I were a betting man, I think more and more would become conversational over time.
Okay. And in order to set up the entire platform as a whole, which basically relies on data, and I also understand that when it comes to the data quality, it's quite bad in many cases, right? I wouldn't say most of cases, but in a lot of different cases. So you'd have to do data parsing and then data cleaning and things like that. Now, what do you think would be a best set of solutions that companies can employ in order to make sure that the data as a whole is good enough in order to onboard software solutions in today's world? especially given the fact that AI is moving towards a more data robust, organization.
I mean, this is probably the hardest problem, right? At the end of the
Correct.
day, process and people is not something you control.
Correct.
Technology is what you control. So, and this, I mean, I don't think there's a very, very easy solution to this, to the data quality problem. What we look at typically is, and the problem is at enterprise scale, it's very hard even to expect people to, I mean, you have a lot of legacy data. You cannot go and clean that legacy data, right? But what we are seeing is, thanks to all these agentic search tools and hints on how what people find relevant, what people don't find relevant. At indexing pipeline time, you can sort of do some of the cleansing of the data or dropping of irrelevant data. That's number one. Number two, because of these agentic search and RAG capabilities, you can sort of input your judgment on what is relevant versus what is not at your retrieval time, right? Because, I mean, so you can solve the problem at two. I mean, if the customer solves it for you, that's the ideal win-win, where they curate the data and give you the clean data. But at enterprise scale, where you have tens of hundreds of terabytes of data, that's a losing proposition. I don't think you can do that. The best you can expect them to do, one best practice you can expect them to do is start doing some data cataloging and cleansing and all of that. I think a lot of this data cataloging and governance helps with structured data. It's a little bit harder with unstructured data. I don't think it's very easy. But what you can ask for is, I mean, I think some sort of rules of thumb on how they think about data, how they think about relevance, what their workflows look like, so that you can embed that into your indexing pipeline at one place where you can embed it, and also embed some of that into your retrieval and ranking time, right? So that's the business process overhead that you can put on top of it. But otherwise, this is a fundamentally hard problem. I don't think this is a, I mean, garbage in, garbage out is a wisdom of nature. So,
and probably that brings me to my next question around reliability, of output. So you mentioned garbage in, garbage out. So more reliable the data, better is the reliability of the output, right? So how do you think that sort of reliability and, let's say, latency sort of scales in such enterprise systems, especially with respect to search?
So let's talk about latency, right? So at least in our experience, given that they are such high value decisions, like optimizing for the last microsecond or whatever is not where customers care about, right? They care more about precision, recall, accuracy, etc. They're willing to wait a little extra, right? So I don't need to do, at least our experience, we don't need to do Google search or scale kind of things, and we don't need to optimize for blazing fast results. It can be a little bit slower. Now on the reliability piece, etc., or whatever, I think the hardest problem, and I think this again is an unsolved problem, I probably don't have good answers for you, is the evals and the eval harnesses that you put in place, right? And this is what we are finding is this almost need to be baked in on a enterprise basis, because our deployments are behind our customers' firewalls. So we are not a SaaS solution. We don't have a one-size-fits-all solution for every customer. There's some layer of customization that we need to do for every customer. So what is critical for us is understanding the user requirements, understanding the enterprise requirements, and building an eval framework for tailored to, or eval set tailored to each customer, right? That is the only, I would say, guard that we have for reliability and relevance. And as new edge cases come in, we keep adding it to the eval set, right? And the held out set, we keep doing hill climbing on. So that's fundamentally the only way that we have to do that is for the pre-production phase, right? Then periodically we also need to have, and again, we are dealing with constraints where because we are behind our customers' ID firewalls, we cannot look at data, we cannot look at outputs, etc. So we have to take whatever feedback, etc. comes from the customers, then look at it within their environments and tweak our relevance algorithm for those specific use cases and add it back into the eval data set, right? So it's not this is the hardest part of the problem. I mean, if you can get your evals right, that's fundamentally the hardest part of the problem because the data set is moving, the models are drifting, data set is constantly changing, right? Even the data distribution is fundamentally constantly changing, which is why it makes it a really hard problem to solve at scale for different enterprises. I would say at some level, Google has an easier problem to solve compared to us because we have to tune for every enterprise. But then again, that's the challenge, right? If you're able to solve this, then we have a home run. So that's about it.
So which would also mean that the evals that work for one customer will never work or may
Will
not
not
work
for
for another customer, right? So which would also mean, which would probably, it brings me to my last question. We are seeing a lot of LLMs out there, foundational models that have been trained on generic data that's available everywhere, right? And some of the benchmarks are also fudged to an extent, especially across all providers. Now, where exactly does the moat lie? Because you sit behind an enterprise firewall. Does it actually lie within deep workflows and you have to come back, play around with different models, and then decide, okay, what works, what doesn't? How do you sort of replicate this across different environments, right? So what's the moat there?
Yeah. So first of all, I think my opinion, the models are not the moat, right? The
Correct.
models are almost becoming interchangeable and fungible, right? I mean,
True.
a difference between frontier model from the US versus what's coming out of these open source models, the delta is shrinking, right?
Correct.
And
Yes.
more and more because of the costs of running these models, what we are finding is many of our enterprise customers want to stay with the open source models, right? Because they can run it on-prem, no data leaks. They're assured that none of this is used for training and all of that. So the model is absolutely, in my opinion, is not the moat. The moat is how do you sort of retrieve this information at scale and build workflows around it, right? It's the context layer, right? I think that is where more deeply you get integrated with the workflows of the customer. You can replicate the grunge work of an analyst, so the analyst can sort of do more higher order work. That is where it starts becoming powerful. The models are fungible. I mean, you can use one model as long as you feed it to the right context, it does the work. So you could use one model today, you can swap it out and use another model tomorrow. It doesn't matter.
Okay. All right. I think that answers all the questions that I had. And yeah, thank you very much, Vikram, for your time. I appreciate it.
Thank you, Hans. This
Yeah.
was fun.
Yeah, sure. Thank you very much.
Yeah.
Yeah.